Hello everyone, welcome to my channel. In this video, I will share you some of the feature transformation techniques that you can use in different machine learning competitions, which can help you rank better in the leaderboard. So before transforming a variable, it is highly advisable to understand that how the variable is already distributed. Now, for example, in this particular data set, I am observing this claim amount variable. So I can see there is lots of zero in this data and it is distributed this way. Now different machine learning algorithms works in different way, they find patterns in different way, and they expect the data to be in different way to perform better. Like the linear models expects the data, all the variables to be in the normal distribution to works best. So it is recommended that you just plot a density plot to see how the data is already looking like, uh, so that you can assume that what kind of transformation you can do to mix your data in such a way that your model can perform better, which can save your time. Now, starting with the very first transformation, that is the log transformation. So it is one of the most common technique, and if you are already subscriber of my channel, you also you can remember that the jobathon that I own in analytics with I used this particular transformation on my target. So if you are transforming any variable or target that has zero in it, so you have to add some value, some number to it, so to prevent the zeros. And here I added 0.01, and after the transformation is done, you can see the data is looking like this. Now it is not always true that after your transformation your data, your models will perform better, because when you are doing some kind of transformation you are losing the original information, but you need to trial and error with different kind of transformation to find if any kind of transformation is working better or not. Now, if you transformed any target, you need to get back to your prediction in the original form. To do that, you need to just because you used logged and added some number, you need to first transform. You use the np.exp, that exponential function, and then subtract the variable that subtract the constant that you added. Okay, and after this particular transformation, you can see that my data is back in the original form. So that is something you should use if you are transforming any target. Now, second is the power up and down transformation. So you, in many other places you may see that there are some transformation like square root or square, or then cube root or cube, but I don't find any difference in it, and also I found this pretty kind of weird, because my data may not be in perfectly square or square root kind of shape. They may be in somewhere between square and square root and cube root. So what you can do, you just use the power you want to transfer. For example, if I wanted square root transformation, I will first use this power to the power 0.5. Okay, and if I run it, you will see that my data will be transferred. Okay, now to go back to the original set, you need to apply just the opposite of it, I mean the reciprocal of it. So just because I used here 0.05 to go back to the original shape, I need to apply 2, that is the square transformation. That is you something you need to use like the previous one if you transform any target. If you are not transforming your target, there is no need to transform the data again, retransform the data again after the model is fitted. Okay, for example, I want to, instead of the square root, I want to transform in the cube. So I will apply 3 here. And here to get back to the original form, I will apply 1 by 3. Now there is something you need to care about, that when you are using this 1 by 3, you need to put this in the parentheses, because in this equation this power sign will work first. If you don't use that, what it will do, it will just it will take to the power of 1 and then divide the entire thing by 3. So please remember to keep the parentheses. Okay, the third one is the reciprocal transformation. So sometimes what we can do, that we do that, we can change the variable to the reciprocal of it. And if I do that, you like just like I use the data of this particular target CLTV here, and if I transform the target, you can see that how the data is almost distributed. I mean, in more in the normally distributed way than the previous one. That is the quantile transformation. So that particular transformers comes in the scalar package, and what you need to care about that if you are just transforming one variable, you need to keep it in is pd.dataframe function, that is pointers dataframe function, because this particular transform does cannot deal with these 1D arrays. Okay, and after that you also need to your if you want to visualize this, you need to use this data function to see how your transformation is looking like. And you can see that it is almost is a normal distribution, but you might think that if this particular transformation is working based, I mean if it is transforming the variable in almost normally distributed way, why we should use the other transformation? But that what I mentioned you earlier, that this particular transformation comes with the loss of the original data, so that particular transformation may perform worse than even than the original data, and you need to do the trials and error of it. Now next two are the power transformation. These two also comes with under the scalar package. Now I am not going to tell you the theory of it, because you can simply google it, that how this box cost transformation works, and you will get the answer. So what this transformation do, it deals with only the positive variables. I mean if your variable don't have any kind of zero or negative value, and try to convert it in some kind of normally distributed format, where the maximum value can be plus 5 to the minimum value of minus 5. But as I mentioned, that you cannot apply with if your variable contains zero or negative value. For example, you remember that this claim amount had zero values. Now if I tried it, if you can see there is this error is coming, that box code transformation can be applied to strictly positive data. Okay, now to get rid of this issue, there is another kind of power transformer. Actually this is the default one. If you do the box cost, you need to mention this argument method is equal to box cost, unless the default is this Johnson transformation. So this deal with both the positive value and the negative value, and even the zero. So if I use this claim amount, you will get the transformation like this. Now there are some things to keep in mind, that most of the things is already discussed. That the first one is this nice looking transformation does not means that your model will perform better. That I told you during this quantile transformer, that maybe it is a perfectly normal or almost perfect normal distribution that may perform worse. Now you can use any other function like sine, cos, exponential if you find certain pattern. So the objective was is to transform the variable to so that my model can perform better. So in the first distribution, when I was talking about this, I told you that the linear model performs better when the data is normally distributed. So if you find this pattern in such a way that it is maintaining some kind of sinusoidal order, or some kind of exponential order, you can transform it in those particular functions like sine, cos, and exponential. And if you want to retransform this, you can use the sine inverse, cos inverse, and then lock to get back to the original shape. Now, the third point is, if you are transforming your target, don't forget to return back to the original shape. That also I mentioned while discussing the first 2 points. Now, one thing I forgot to mention, that these scalar transformations like quantile or box cost, you cannot transform to target because you will not be able to retransform it to the original shape, and your prediction will not give you the value that you wanted. Okay, now the fourth point is the extension of the third point. You cannot use cross validation directly in case you transform the target. So when you suppose you are your evaluation matrix is root mean square error. So suppose you use square root transformation, so the value will be lesser and the root mean square and the error of the root mean the root mean square error will be lesser also. But that will not give you the idea whether my transformation is working better or not. So it is highly advisable if you can separate the uh, five sets of validation set and the training set, and then the use the cross validation there. But there are some packages that comes with the cross validation internally, like FLML. They directly work on the cross validation, so you cannot use it. I mean, when I am saying that you cannot use it, that means you cannot use it to get some idea that if that particular transformation is working better than the original or not. So I hope you enjoy this video. If you have any question, you can mail me or reach me to the LinkedIn via LinkedIn. This is my LinkedIn URL that I mentioned here. Okay, you will find me there and text me anytime. And if you like this video, you can subscribe to my channel to get update for more useful videos in data science and machine learning. Thank you so much.